my name is Jeff Badger. I'm an expert in grinding, did various degrees in mechanical engineering and then a PhD in mechanical engineering with a specialty in grinding. I call myself the grinding doc. I work as an independent expert consultant and I visit companies around the world and help them with grinding. And COVID has changed things a little bit in my life, so I have a little bit of extra time now, not much overseas travel. I have a good relationship with Jarvis Cutting Tools. I've known Costigan for maybe 15 years now, and worked on their grinding operations. So this week I am here because we are messing around with thread grinding in taps. This is kind of a monster-sized tap, but we have this as a demo here. And you have to grind the flutes and you have to grind the threads, and we're talking this week about grinding the threads. Thread grinding is a cylindrical grinding operation, and we're working on a project where we are going to optimize their thread grinding. And I've done this at a lot of different companies and a lot of different grinding operations. I've done it at the International Grinding Institute, and the process is pretty straightforward. The differences are really in the geometries. And so what we're doing is we've hooked up the grindometer today. We're measuring power. And then we will use that to predict grinding temperatures, because if you have a tap in high-speed steel and the temperature gets too high, 500, 600, 700 degrees C, you get residual tensile stresses, over-tempering, and rehardening, and we don't want that to happen. So we predict temperatures with a thermal model. And then if you've ever taken any of my grinding classes, we do a no-dress test to figure out the wheel wear profile. And then when we do that, we can predict the wheel wear. Typically in the bottom of the thread is the dangerous area. And what we really do is we calculate the G ratio. And then we can predict what the wheel wear is going to be based on the size of the tap, the amount of material we got to remove, etc., etc. And then we can say, okay, here's the amount you need to dress and how frequently you need to dress, saving yourself lots of wheel costs and cycle time too, because dressing takes time. Then we predict temperatures and we say, okay, we are going to predict the temperature and then keep the temperature below the burn temperature. Number might be 500 degrees C. And then we can use that to optimize the process. So you say, hey, I've got some geometry, probably not this big, and say I've got some thread length, because the more thread length you have, the more wheel wear you're going to get. I've got some grade of steel, because different steel grades behave differently, so we're going to work on that this week too. Some grades generate a lot of heat, some less heat. Some grades generate a lot of wheel wear, some less wheel wear. So we will get the baseline for 3 different grades. And then we will use that information to tell the operator, all right, man, if you want to grind this tap and you want to do it in a short time, here are the parameters you should use. Here's the depth of cut you could take on the various passes. Here's the number of passes. Here are the feed rates to take, wheel speed. Here's what wheel speed you want. Here's how you want to dress the wheel. So the operator isn't really just kind of throwing darts at the dartboard hoping something works. We actually give him parameters that will give him no risk of burn, less wheel wear that'll hold form, and then get his cycle time down as low as we can while maintaining those parameters. So I'm here this week basically just measuring everything to get all the information, measuring it with my grindometer, doing no dress test, getting all the geometries, and then in November we will put it all together in a program to tell you, all right, here are the parameters that you need to use, and then we'll come back and validate it, make sure it works, make sure the operators like it so it's user-friendly. Sophisticated program that the operators don't like is a worthless program. So we want a sophisticated program that the operators find easy to use, user-friendly and practical. So that's why I'm here this week, hanging out. Costigan will probably take me out for lobster. He usually does. It's cold, it's miserable, it's rainy. It's New Hampshire in October, but
yeah,
life.
that's life here.
That's life. Life's got to go on in grinding, anything for the grinding world. So